Hello everyone, in this video we are following chapter F4.3 Clouds and Image Compositing from the book Cloud-Based Remote Sensing with Google Earth Engine. We will briefly try to understand the concepts and we will also go through the codes. So, cloud cover is one of the limitations of the optical sensors. It hinders the process of continuous monitoring of the surface. Clouds and the cloud shadows reduce the view of the optical sensors, and it blocks the spectral response from the Earth's surface. It also influences the accuracy and information content of products negatively. We have different cloud detection algorithms, and some of them are based on the analysis of Landsat time series. In the Earth Engine dataset, or simply in the images that we are provided, we also are given with ancillary data. And this data contains some quality flags at the very pixel level, and we use them to mask the clouds. So here is the brief process or the steps that has been shown in this chapter. So we define the area of interest, we filter the image collection based on the parameters, we apply some cloud masking, cloud marks, and then we reuse the image collection to generate a composite image. And we will briefly see this GEE BAP application to generate the image composites. So this is the very first section of the course. We have here the variable name country. We are filtering this feature collection to get the country that is Colombia. And you can see this is being done by dot filter. And we have this ee.filter.equals where F is capital. We're centering to that country with the zoom level 5. Then we have the start and index. And we are filtering that image collection based on the country and also based on the dates. That is the start and index. We have the function here where we are selecting the bands and we are multiplying with some constant and adding here, actually subtracting. Then we're also selecting the thermal bands and then we are multiplying it with some constant and adding some constant. And we are returning the image with the bands added to the original image. Here we are mapping that function where we apply that function. Then we are getting this, we're creating that image composite. This is very simple. We do this by dot median to the image collection, and we're clipping that for our area. Then we have some visualization parameters with bands and then minimum and maximum values. And then finally, we're adding it as a layer. We can also filter the image collection based on the image properties. One of them is the cloud cover. Here we want the cloud cover to be less than 50. And this also reduces the number of images in the image collection. So here we can see the size that was original. And after using this cloud cover, using this cloud cover filtering function, we get the image size to be very less compared to this original size. And the other important one is the cloud masking function. Here we work with this QA pixel, and this has the useful information on the conditions that can be applied per pixel level. So here is this dot bitwise and parse int, and this is something done in the binary operation that takes two equal length binary representations, and it basically performs the some kind of logical operations on each bar to return some integer. So to understand it, basically means we want to mask the clouds, and we also have the saturation marks, and we just marks the clouds by this bitwise operation. And then we apply that cloud masking to the collection. And again, this is done by dot map here. And then we do this dot median to get the single image. And what we see here is the first composite, where we see the presence of clouds. Then we have the cloud filter here. And then we finally get the masked image, but we can see there are some gaps in the image. Then we have the second section, where we are also trying to merge the image collection with the with two different sensors, and Landsat has the longest history of image collecting the images. So we have here the Landsat 7, and for that Landsat 7, we are applying some scale factors, we are selecting some bands, multiplying with some constant and adding some constant again, and same thing for the thermal bands. And we do this process that was done similar to the Landsat 8. Here we can see we are filtering our Landsat 7 images based on the area, based on the dates, and also based on the cloud cover percent. And we are mapping these cloud masking and scale. We're also applying some scale. And then we get this single image, that is the median image by dot median. And we're also clipping for the area. And here we are adding that as layer. And the important thing is that Landsat 7 and Landsat 8 have different band names. For that, we are selecting the bands, and then we are renaming it based upon the name, which will be same to the Landsat 8. And here we are applying that function, that is the renaming function. And then here we are merging two different image collection, that is for Landsat 7 and Landsat 8. We have all the masking done, we did the renaming, and for the Landsat 8, we also masked the clouds there. And then we just do the smars, and we get the very long list of images here, about 972. And then we do these, finally we do this dot median, and we get the single image based on the Landsat 7 and Landsat 8. And this is the image here. So this solves the process of getting the median image, where we are merging two different data or two different Landsat satellites. And the third one is the app here, that is the GEE BAP app. This stands for Best Available Pixel Compositing Earthengine application. We run this, and we go to the we get this in the reader section, and we click the UI. When we run this, we get this interface where we kind of input our area. We can draw the area, or we can also do some. This already has some templates there, and we are provided the chance to select the years. We can download the images. We can provide some acquisition dates. Then we can also slide the cloud cover in the scene. And there is some SLC of penalty. This is for Landsat 7. As there was SLC failure, where we get the zigzag line type of images. So these are different parameters there, and what we get is the composites of the images. But for the other case, we can also apply the same thing here in the code section. So here we have the different parameters, and this BAP, or the Best Available Pixel Compositing earthengine algorithm, let's say, has these different ways there. That is the compositing, the spiking, data gap infilling, and some other displaying functions. And here we are again selecting the country, and we import the library, and then we are providing different different parameters to that algorithm. And what we get here is the, again, cloud-free images. The process is to get the cloud-free images, and what you see here is like this. So before there were some gaps, this time there are no gaps here. Please refer to the chapter for understanding this this algorithm or this BAP earthengine application. But the overall idea is that we just need to remove the clouds and the and we just can do some masking there and try to work with changing the dates, maybe working with 2 different sensors. So this is the idea of this chapter, and this is it. I hope this was helpful to you. Please comment for any discussion. Thank you for watching.